Alright, good morning, guys. Hope you guys are getting your extra hours sleep with daylight savings. Let's talk about critical control points and preventive controls. So, here's what we'll talk about today. I'll cover a little bit of what we discussed in the last couple of weeks with hazard analysis and the internal auditing process, and then we'll get to the lecture proper. And I might discuss a little bit about how you can apply this lesson to your project afterwards. So, a couple of weeks back, I introduced you guys to the process in preparing for a true HACCP or HARPC program, the development of such. So actually, before discussing either of these topics that you see here, one of the first things I did was introduce you guys to the preparatory steps, or we call them the preliminary steps of developing a HACCP plan. And much of that applies to HARPC as well. Then I discussed to you guys the importance and the many types of good manufacturing practices, or GMP programs that exist. Having a strong understanding of all of these is great for these particular lessons which we covered recently. So for the intro to hazard analysis, I introduce you guys to the process. In short, it really goes like this. You go through every single step of your process flow diagram. So you build a flow diagram beforehand. Or at the very least, you know all the steps that go into making your food. Then at each step, you sort of take into account all the sort of likely biological, chemical, and physical hazards that may occur at those steps. You try to think about the risks involved with those. For example, let's say you're doing a pasteurization process, like you're doing working for like let's say a milk company. Well, you got that milk pasteurized, right, in order to protect it from bacteria. What specific problems arise when the pasteurization step is not done properly? Well, if pasteurization isn't done properly, you run the risk of E. coli, salmonella, even listeria. Those often have to be taken into account. And you would know that they're biological hazards, so what can you do to stop them? Well, you need to check to make sure that it's cooked at the proper temperature and for the pre-designated amount of time that your team was able to prove was valid for destroying the bacteria that are in the milk. Really, the true challenge comes from determining which sort of hazards are most likely to occur in your operation at that step, assuming that it's being operated normally. As your textbook and many other food safety sort of guidances tell you, you want to consider the hazards that are reasonably likely to occur through contamination or cross contact if you're talking about allergens. As far as GMPs are concerned, we talked about the internal auditing process. So this is the process by which you monitor and verify that the good manufacturing practices in your facility are being followed as they are written. So I talked about the many things that you would typically look for in an internal audit, and that even that wasn't exhaustive. There are a bunch of different things depending on what kind of company you work for. You talk about the planning process, what you do in case there's some deviation from that process, like you check a no or a fail somewhere in your internal audit, what to do about it. That was all covered in that lecture. Actually, the two different lectures that we had for internal auditing. So I'll suggest you review that if you don't remember it. Okay, and then that brings us to our current lecture today. We're going to talk about like going from the hazard analysis, what to do once you identify key points. And there are two different ways to do this. This is through HACCP, you can do the CCP's method, or through HARPC, you can do the preventive controls method. And we'll talk about both today. Spoiler alert, both HACCP and HARPC are perfectly valid ways to analyze food safety in your facility. But having worked with both, I personally find HARPC to be a little bit easier. But if you're worried about your grade, don't worry. Both will get you full credit if you do it properly. That's just my personal preference. But anyway, back on topic. Let's talk HACCP and HARPC. So as far as the difference between HACCP and HARPC, though both are perfectly valid ways of analyzing the potential food safety issues in your facility and addressing them. It's just that their approaches are different. So we talked about this before somewhat, and I see that some of you, from at least judging from the midterms, you guys seem to grasp this concept already. But at their fundamental core is I guess the rule of thumb that they use is a little bit different. In HACCP, when conducting a hazard analysis, you want to think about the possible ways that you can control the hazard or reduce it to an acceptable level, like either prevent it, kill it, or at least bring it under control, I should say. These are called control measures under the HACCP framework. And the main goal of a HACCP plan is to narrow down the most important controls that need to be in place to control food safety in the facility. So, at all points there might be some sort of like GMP program in place, or maybe some sort of prerequisite program. But as far as what HACCP focuses on, they just want to narrow it down to like just a couple places that can be where the food safety team can exert the most control over the process to make sure that food safety is always applied. As far as how that contrasts with the HARP C mentality is to really control everything. So each step of the process that reasonably requires some sort of extra dedicated measure of any kind, really, whether that's through something similar to a CCP, we'll call it process preventive control, or through three separate ones, and we'll talk about them in a bit. Um, is just does this require some sort of food safety measure in place beyond GMPs? If yes, then yes, it qualifies as a preventive control point. I really want to save it for later, but I guess it makes more sense if I give a specific example here. So let's say you're doing like a pasteurization process for milk. For milk, regardless of what you do, you have to make sure the equipment's sanitized. You want to make sure you pasteurize to the right temperature. You want to make sure that the milk is stored in the refrigerator properly. Under a HACCP style plan, only the pasteurization will get any real focus there. It'll be considered a CCP in that case. Whereas with HARPC, all three of the things I mentioned would have some kind of preventive control. Controlling the refrigeration as well as the pasteurization temperature and time, those would be called process preventive controls. Whereas the cleaning and sanitation of the equipment would be considered a sanitation preventive control. If this doesn't make sense to you yet, no worries. We'll be talking about them in a lot more detail in a bit. I just want to give you a general idea of how they're approached differently. And in reality, you don't have to really pick between one or the other necessarily. In fact, most SQF certified programs that I know of, the facility tends to combine the elements of both together and still call it a HACCP/HARPC plan. The point I'm trying to make is that the goal is the same. It's just that the way that it's executed is a little bit different. That's all you really need to know for now. So in the HACCP process, each particular step of the process is called a control point, just a regular plain old control point. This is a step of the handling of food which contributes to the overall process. So it doesn't have to be even for food safety reasons. It can even be for quality, whether you're chopping the product, whether you're storing the product in the fridge, whether it's being pasteurized, whether it's being shipped out. Everything, including the most important food safety controls, will be a control point. Every particular step of the flow diagram. But the steps most critical to the food safety of the product, those will be classified as critical control points. So yeah, if you take a look at the flow diagram on the right, you can see some of those points are just marked CPs. Those are not really essential to food safety. That's just part of the regular part of the food process. Maybe some GMPs might be applied there to maintain food safety, but they're not the most important points as far as removing or preventing contamination from the food. It's only those that are marked as CCPs that are gain the most focus. Now, what exactly is a CCP? If you want the precise definition, well, here it is. And this is from the Food and Agriculture Organization. This is an international sort of food industrial business sort of private organization. You'll encounter them at least once in your career. But anyway, a CCP is a step in which a control can be applied and is essential to preventing or limiting a food safety hazard, or at least reducing it to an acceptable level. So these are steps that are so critical to the process as far as keeping the product safe that if these were to fail, suddenly you've presented yourself with an unacceptable food safety risk to your product that may require recall or some kind of correction or something like that, or I should say corrective action. So these are like the key points, like sort of like strategic points as far as where food safety is concerned. These are really the pillars to maintaining a safe product in your facility. These are the most important parts of the HACCP plan. Precisely what qualifies as a CCP really depends on the type of facility, because not every cooking process is for food safety reasons, and some things which you wouldn't think would be that important, like in label right, may actually be very, very important. In this case, like if you forget to label something on a product, that could be a problem when you need to protect your customers from allergens. So there's a certain process that goes into defining a CCP for your process, what they would typically look like, and or like what they would typically be for your particular product and process. And then from there, it's just a matter of deciding at each point whether or not that CP qualifies to be elevated into a critical control point. So there are different ways of determining whether or not a control point should qualify as a CCP, but the most often taught method is the decision tree. It's basically a chart that you draw out. You ask yourself a bunch of questions, yes or no, and then as you answer each question at each point of your process, you just go navigate through that tree that you made to sort of like walk through the process at each step to see whether or not something objectively qualifies as a critical control point or not. I'll show you a real example in a second, but let me just get you through the basic logic behind this. So let me give you a really oversimplified example of a decision tree about deciding whether or not you want to eat, and depending on what kind of funds you have, whether or not you want to eat at home or you want to eat at a restaurant. So it goes like this. Start with the first question. Am I hungry? If you're not hungry, great. No need to go any further. Just go to sleep or go do something else. You're not hungry, there's no need to eat. If you are hungry, then you need to ask yourself another question. Do I have enough money to eat out? Or I guess in this case I put, do I have at least $10 on hand in my wallet? If I have at least $10, great. I can afford a Big Mac or like some sort of breakfast deal at like some breakfast chain nearby me, like a Denny's or whatever. Okay, great. I could go to a restaurant. So if I have at least $10, yes, I go to a restaurant. But if not, well, I'm hungry, but I cannot afford to eat out, so I eat at home. So that's a general idea of what a decision tree is like. Now that I've given you that oversimplified example, let me show you the real thing that's been recommended as far as a CCP decision tree. So this is not the only CCP decision tree in existence, but I thought this was a pretty good one. Let me walk through it with you right now. So the first question that's asked in this particular framework is, do preventive measures, or I guess control measures, exist at this step or subsequent steps for the identified hazard? So whatever hazard's there, is there something in place to keep it under control? If not, well, you follow up with a certain question like, is the control even needed at this step? Well, if it's not needed at this step because it's being done later, then that's fine. It's not a CCP. But if you do need to control the step and it's not there already, you might need to modify the process. And then you go back to question 1 again. If there is a preventive measure or control measure in place, then you need to start asking yourself the second question. Does the step eliminate or reduce the hazard to an acceptable level? So like, does it get rid of it or does it at least keep it under control? Well, if the answer to that question is yes, then you got yourself a critical control point there, don't you? If that is the case, mark the step as a CCP and move on. Well, if it's not the case, then, well, you need to ask yourself a third question. Could contamination with identified hazards occur in the excess of acceptable levels, or could these increase to unacceptable levels at this step? Well, if there's no chance of those hazards becoming a risk if that step fails, the answer would be no, and then, well, it's not a CCP. Thank goodness. But if it is, then you got to move on to the last question, question 4. Will a subsequent step eliminate the identified hazards or reduce the likelihood of recurrence to an acceptable level? Well, if that's not the case, like that's the last step in which you need to control the hazard and you have nothing later in the process to help it, then unfortunately you do have to treat that as a CCP because that's kind of your last line of defense there for that particular hazard. But if there is a step later in the process that will take care of it, that particular hazard, then you don't have a CCP. So that's kind of the process by which that works, and sort of the questions you ask yourself at each step. If you're using the HACCP framework, you have to do this for each step of your process. So this is how you would mark CCPs on a hazard analysis map. When you identify the certain hazards in your hazard analysis, you want to classify the different types, biological, chemical, physical, and you want to consider, are any of these hazards significant? Like, is there a likely risk of it happen? And if it does end up in your food, does it cause a huge food safety issue? Will it cause foodborne illness or injury? You might give some reasoning for it, like is it likely to occur? Has it happened in the past? Is there scientific or proof or is there regulation that mandates this sort of control? And then from there, you make your decision using that decision tree, whether or not it's a CCP or not, and you just mark it accordingly. You can use this as sort of just a visual example of how you would mark CCPs on your hazard analysis. We'll talk more about this in a bit one after I've covered preventive controls as well. But this is just the general format of what it will look like as far as identifying CCPs on your map. I mean, on your hazard analysis. Now, we don't have time to go through all the CCPs in existence. If we did that, this presentation would be at least 4 or 5 hours long. Because what qualifies as a CCP depends on the intent of the process step. It depends on what kind of product you have. What sort of risk factors are there for the people or animals or whoever's going to consume it. What is the purpose of that particular final product? Especially if you're just making something that's used as a raw material for something else. That could affect whether or not something qualifies as a CCP or not. Whether or not your product is intended to be raw, ready to eat. There's just too many. But if you want some like common CCPs, these are by far the most common. I see these more often than any other CCP out there, as far as the various examples that are in place. So there's any step intended to control the product such that it's either designed to remove any sort of pathogens, like biological hazards, bacteria, and whatnot, or at least stop them from growing. That would definitely be a CCP to consider. So if your cooking step is specifically for food safety reasons, you're trying to boil it, you're baking it, you're frying it, just to kill germs and to make it safe to eat. If that cooking step is for that specific purpose, that would be CCP. So you would think all cooking steps are it, but like I've mentioned this before, not every single cooking step in a manufacturing process is for food safety purposes. You remember that McDonald's video I showed you guys some weeks ago when they made those chicken nuggets? They were not frying the chicken nuggets to make it cook and safe to eat. They're just trying to set that batter, and so that would not be CCP. Now, if they're making those chicken nuggets on site, like to the finished product to make it safe to eat right away out of the bag, or like to a point where it's frozen, all they have to do is like microwave it, that'd be different. Then it would be CCP. But in that particular case, all they're trying to do is like change the batter, so that would not be a CCP. If you have a drying, deep freezing, um, some kind of salt addition to your product, like the fish sauce example from the midterm. If you're trying to alter the pH, you're trying to acidify it to make it safe from Clostridium botulinum, for instance. If you're using high pressure processing, like for guacamole, or really any process designed to control the bacteria, its potential for growth, or killing any that exist on there already, those all qualify as CCPs. If you work in warehousing or distribution, you still need to consider CCPs, and that's kind of its own level of challenge because you have no thermal controls there. And so everything from the receiving, storage, and shipping will all qualify as CCPs because for a frozen seafood, you got to control that temperature, and the only way you can do that is by controlling the time in which food's left out, the condition of the refrigerators, and stuff like that. So for a distribution facility or for raw products or ready to eat sort of thing, any sort of storage step or any sort of shipment step where products being moved around will qualify as a CCP. If you're trying to control physical hazards like metal, wood, and stuff like that, well, in this case, in particular, metal, any sort of metal detection step, all processes in manufacturing have some kind of metal detector. The metal detector would be CCP in most cases. And then for allergens, this one actually isn't. Well, I should say it's neglected a lot actually. Labeling is actually a very important CCP for any sort of allergen control because not if you forget to label an allergen on your ingredients list, that's actually a pretty common case for, a pretty common cause, I should say, for recalls, and so labeling should be considered CCP too. So those are the most common, and your textbook, as well as many different websites, have a lot more examples. I even put a bunch up more in the recommended reading section on Canvas. More of that at the end of this lecture. But these are by far the most frequent that I've seen. And so if I want you to memorize any sort of CCPs, these will be the ones that will commit to memory because these are the most common. All right, now that we talked about HACCP, let's talk about HARPC. And so HARPC is very similar to HACCP in its goal. It's also trying to identify key process steps that are most important to food safety. But like I said, it does things a little bit differently. And so the main question is not whether or not something is so critical to food safety that it failing would compromise the overall safety of your product. It's just whether or not that hazard requires a special control of some kind. Whether it's sanitation, whether it's just making sure that you make sure you have a good shipment when you receive it. In addition to many of the things that you would treat as real CCPs too. Um, or even if you just need to do any sort of pre or post preparation to make sure you prevent things from happening. Those all qualify under this particular sort of framework. And so all the things I mentioned before, those are called preventive controls. And actually, the weird thing is when I looked in the FSPCA manual, I don't see a real definition for preventive controls, which is odd. But I found this one in the guidance. Basically, these are all the steps in a domestic or food facility. So basically, your company that makes the food. These are all the steps that are taken and must be taken in order to reduce or eliminate food safety hazards in your facility. So this isn't just the most important ones. This is any that would apply to your particular process. Okay, so there are technically more than four, but in most cases you'll only ever use these. And so these are the main preventive controls I want you to know. And they are supply chain, allergen, process, and sanitation. So these are the four main ways in which a preventive control is applied in a HARPC plan. And as far as how they would show up in a HARPC plan necessarily, well, let's say you identify a step in the hazard analysis that requires a preventive control. So let's say for just any random hazard, going back to the dairy example from the beginning of this lecture. So the pasteurization step requires a process preventive control because the pasteurization is a way of controlling the biological hazards that could show up in that step. Or I should say the biological hazards that are likely to grow as a result of neglecting that step. So if you were to imagine that hazard analysis chart again, basically where you would put that it's a CCP and that the hazard is significant, just swap that out with hazard requiring preventive control and what type of preventive control you're applying. And just like you would for a CCP chart, you have to analyze each of these preventive controls in more detail, or at least describe them in more detail, and create some sort of way of making sure that they're effective, monitoring, verification, documentation, all that. But the way it's done is slightly different for some of them. Again, I'll talk about that a little bit, but let me elaborate more on these preventive controls first. So, as promised, let's talk about these in detail. The first of these is the supply chain preventive control. And basically, the way this preventive control is applied is you're basically relying on the supplier to do the hazard control for you. That might sound lazy on paper, but actually, in some cases, it's your only protection. Your company might not have the capabilities and resources to do the hazard control on its own. Or maybe your facility's operations are such that you don't control for the hazard on site. That's something that the original farmer or the original manufacturer had to do on their own. The easy example I could give for this to make it clear is aflatoxins in grains. You can't really cook that away, can you? You kind of have to rely on the original farmer or grower to actually screen that for you. And so you apply a supply chain preventive control that way. Also, at my own job, we have a lot of meat that's supposed to be boneless. But then as of late, we've been finding a lot of bones in some of those shipments. And so we kind of have to hold our suppliers responsible for that. And so maybe I should apply a supply chain preventive control for bones specifically. As a general rule, or so I've been taught when I was doing the PCQI class, you want to make sure that you want to rely on a process preventive control or something stronger than supply chain if you can do so, if your facility is capable. But if not, then supply chain is really all you can do. And so supply chain should be one that you should consider, at least for the first line defense against some of these hazards. The next one's allergen preventive controls, and the FSPCA/FDA loves this one. They talk about it a lot. So with allergen preventive controls, you want to apply this preventive control whenever there's a certain step where cross contact with other allergens is likely, or there is a very real risk of it. Let's say you work for a mill that makes a lot of dry products. So they grind a lot of seeds and like plants together to try to make like powders and stuff like that. Let's say you make both rice flour and wheat flour. We want to make sure that that wheat flour does not cross contact with the rice, right? So you could do your best to like sanitize and clean the equipment in between batches and whatnot. But there are two problems with that. One, that's not really practical to do, especially for smaller businesses, because they have to sort of like keep processing nonstop, or at the very least, very short breaks in between, and sanitation takes a long time. And two, cleaning, while helpful, does not guarantee you safety from allergens. So the best thing to do is to prevent it from happening in the first place. And one of the most common ways to do that is to schedule production on separate days. So like the rice flour would be done on one day, like maybe at the beginning of the week, and then the wheat flour would be done at the end of the week, and then a deep clean is done afterwards. If your company has a budget for separate rooms, that's great, and that's what you should be doing. But that's actually a more common example when the same equipment is being used to process multiple different things, some of which could contain allergens. And that's pretty straightforward. Just make sure you do some things to ensure that like whatever allergens are in your facility that they're kept far away from other things, such that there's no risk of any like residue from that like coming into the food that's not supposed to have it. This is where it gets kind of iffy. Some companies I've seen it both ways, where they have it as a sanitation instead of an allergen control, or the allergen control is a sanitation process. But like I said, that's not really a guarantee that you're going to protect your food from allergen cross contact. So the thing I said about scheduling or keeping them separate, that's usually a better way to go. This is, at least to my understanding, one of the main reasons allergen preventive controls is treated as its own thing, as opposed to being lumped in with sanitation. Actually, while we're on the subject of sanitation, I might as well elaborate on that. So, the sanitation preventive controls are the processes and procedures that you guys use to prevent the spread of biological hazards. Sanitation and deep cleaning are also ways that you can get rid of allergen residue too, so it's used for that purpose as well. But this focuses on the environmental sort of contaminants, as well as any sort of contaminants from raw materials that could be retained onto the equipment after processing. If equipment is not sanitized properly, especially for anything that's raw produced, that can be a huge headache as far as salmonella and E. coli contamination can be concerned. We're actually dealing with that right now in my company. We make a lot of raw food for cats and dogs. Not cleaning equipment properly can definitely be a huge source of contamination for the aforementioned hazards like E. coli, salmonella, listeria, and all that. So this is a very important preventive control in and of itself. So everything from your procedures to your policies to what sort of equipment and parts of the environment are to be tested on a regular basis to be monitored for signs of bacterial contamination. That's a key part of a sanitation preventive control. And then last but not least, the process preventive controls. And this one resembles the CCPs the most for HACCP because these are the preventive controls that are applied specifically during the process. Any sort of parameters you adjust through a machine, like the temperature and the time, any sort of manual precautions you need to take about like pre-preparation and sanitation or any sort of quality control checking, those all qualify as process preventive controls. Now, whatever CCPs or preventive controls you identified, you need to do something with them. It's not enough just to list them. You need to actually write them down and flesh them out. Here's how you do it. Basically, when you identify a CCP or a preventive control at a certain step, you need to give the reason, and that's called a justification. There are all sorts of different ways you can justify this. You can either cite a source, a well-known industry source, or even a government regulation. That's actually even better for controlling that hazard, why it's so important. You can use previous data from when you've been operating in the past. It's like, has that always been a problem? Has it been a problem sometimes? Has that never been a problem? To sort of give you reasoning for why that might be a target point or not a target point. There could be more than one type of hazard at the same process step, so you need to specify which particular hazards exactly are being controlled by your CCP or your preventive control. Then you need to know how to judge, and we'll talk about this going forward, but you need to judge whether or not your CCP preventive control is working properly and that the hazard is being controlled. You need some sort of metric for that, and that's called a critical limit. Then once you know that metric, the critical limit you want to pick, you have to find some way to actually check it, like a method for checking that critical limit. So that's a monitoring procedure. You need to know who, what, when, and how often you want to do that monitoring process. And I'm seeing a typo here for preventive actions that actually should be corrective actions. So what to do when something goes wrong and you monitor it, you detect it, you need to do something about it. What is it exactly that you'll do if you need to correct a something that which passed its critical limit or failed to meet it, whatever it is? Then you need something to check whether or not it's working at all times. So like something to sort of, I guess, monitor the monitoring procedure in a sense. In some cases, like a calibration of equipment, training of employees, maybe some sort of audit which checks the equipment at different times to make sure it's working properly and actually measuring accurately. If you're working on a manufacturing process for the first time, if it's supposed to be CCP or preventive controls related, you might have to validate it. Validation is actually a scientific proof that it works through a third party, or you can do it yourself if you have the equipment and expertise. Again, more on that later. And then, of course, you'll want some way to document it, so documentation, which is not on here. Let me show you the table that you would use for analyzing a CCP slash preventive control. They're not exactly the same, but a lot of it's crossover, so I'm going to show you one table, and it should be good enough for both preventive controls and CCPs, at least for some preventive controls anyway. So this is what a CCP slash preventive controls chart would look like. Again, breaking down what I've listed on that slide earlier. So here's a little bonus specific to preventive controls. So what I showed you should work for all CCPs and at least for some types of preventive controls, specifically those that are which do allergen or process preventive controls. But there might be some other ways you want to flesh out preventive controls document on your plan. You are required to list all of them, whether or not a particular preventive control applies to your facility. And so, in some cases, it may not always make sense to create a chart that was designed for a CCP. Some other method might make more sense as far as explaining how your program works and making it easier for you to enforce on a day-to-day basis. So let me show you some of the alternate formats that I've seen for the other preventive controls, specifically the allergen, the sanitation, and the supply chain. Let me just make a quick disclaimer. What I'm about to show you is not the universal template. In fact, there's really no fixed format for any of these preventive control charts, but they're the most common as far as what I've encountered. In addition, keep in mind that what I'm about to show you are simplified versions of what you would normally see in a real food safety plan. A lot of that's just because I don't have enough space on these slides. So I would suggest you actually look up real examples if you want to use this for your project. Consider this more of a Cliff Notes version of what you would see as far as the preventive control alternatives that are out there. So this right here is the supply chain preventive control. You can see some here the general format. So you want to describe the purpose of the document, how often this procedure needs to be followed, who's going to do it. Of course, the procedure itself. You can even just reference an existing SOP that you have instead of doing this, but this is just showing you like a general format. The key component here, or the key components, I should say, of this supply chain preventive control are first, you want to describe the way in which you verify whether or not your ingredients come from the right supplier. And you would also even have to flesh out like sort of the procedure by which you determine whether or not a supplier is suitable for your needs in the first place. So, in a sense, reference to your supplier approval program. You might list out some of the ways you can tell whether or not a supplier is going to be able to comply with your needs. You can do it through a description of supply approval program process. You might describe like certain things you will look for in their food safety audits or the certificates. You want to make sure they have some sort of documentation showing that they control the hazard specifically, like something in their letter guarantee saying that they target the specific hazard that you're looking for. Maybe it's in their food safety plans that they share with you, their flow diagrams, whatever the case may be. And basically, you list that out. Once you have the list of approved suppliers and your ingredients, you create a chart. And so that chart is the second component I'm talking about. That's essential to supply chain preventive control. You want to list all the ingredients that fall under this particular preventive control. So, like, if a particular ingredient requires supply chain preventive control to be kept safe in your facility, what is that ingredient? Who's the guy giving it to you? What sort of hazard are they controlling for? And how do you know that their supplier is following your requirements? So, in this example below, this hypothetical company buys a lot of raw beef brisket and a lot of raw cheeses. Well, raw cheese isn't pasteurized, so there's always a risk of Listeria monocytogenes. But they know the company that is supposed to sell them their stuff, and they know what sort of controls are applied by that dairy company to make sure that their milk and cheese is safe, basically, despite the fact that they have no pasteurization step. What is it that they do? The controls applied. Hopefully, that particular process has been approved by a third-party auditor. This is why stuff like GFSI and GMP certs are so important. This company might ask for, in this case, First Street Dairy's HACCP plan or like a snippet of it showing that they have a specific step for making sure, or like maybe some sort of description of the program for sanitation and environmental monitoring, or maybe they apply sanitation preventive control. They need some sort of proof of that. Then on top of that, an auditor described the process as being adequate, so they're actually following that written plan. And so you have keep records of not only the HACCP plan and the supplier approval program. How you actually verify it is when you know that the First Street Dairy is certified as under GFSI or GMP or whatever it is, and you have that on file. And so that's the kind of the way that you control the supplier approval or the supply chain side of it. For meat with raw beef specifically, a lot of animal carcasses still have like dirt and feces on them. Meat plants can be pretty darn nasty, and so there might be some sort of control in place, like a CCP involved with like washing or inspection or at least some sort of way to actually control for any sort of filth that might be on their meat that they can get rid of on the spot while they're processing the carcasses and the parts for use in other things. So that raw meat plant should have a way to control for E. coli in there, whether it's through environmental monitoring, or actually that's one component of it. The other of it is actually getting that dirt or fecal matter or whatever else is contaminating that beef carcass off that beef carcass. And so it'll be pretty much the same thing. You want some proof of it in their HACCP plan, or if they don't disclose it, maybe they give you a letter describing what they do. They should talk about the sanitation environmental monitoring program. And as long as they can prove that a third-party auditor decided that, yeah, their food safety program meets like GFSI or GMP standards, whatever it may be, like HACCP, the program is strong, robust, and it's actually being followed, then great. Once you have proof of that certificate, that's enough proof for you, and you have that on file. And really, this is just one of many examples. There are other ways you can verify supplier as well. Some companies are too small to have or to be able to comply with supplier approval programs, so there may be some other way to address the issue, like maybe through reliable shipments, inspection every time you receive a shipment, make sure that all the paperwork associated with it is accurate. That's why I've included in here like a separate procedure for the receiving clerk, and this is pretty typical actually, where the receiving clerk will actually check to make sure that the shipments of meat or cheese come with the appropriate paperwork, so they know it came from the right supplier. They know that through whatever documents like food safety related that may come with it, like a COA, that's inspected to make sure they have been checked for like E. coli, salmonella, and whatnot, or I guess in this case E. coli, listeria. And if not, whether there's no paperwork or the paperwork's bad, just send it back. Follow like a hold reject procedure. So yeah, that's just one of many different ways you can apply supply chain control, and this is what a typical one would look like, at least the first page of it. You see that asterisk there, like I said, you also want to make sure you flesh out that approval process or a supply chain verification process, maybe on a separate page or maybe right below it. But this is generally what you will see in a supply chain preventive control document. Okay, so this one is specific for allergen preventive controls. You would have maybe the process preventive control or CCP analysis chart that to go with it. But this is always added on top. You create essentially like a table the different allergens that exist in your facility among all the products that are covered in your HARPC plan. And so it will kind of look like this, where we have a list of different products. If your label has the product stock number or the SKU, if you don't remember what that is, go back to the inventory control lecture. Um, but either way, you have a summary of different products that are covered on the plan, the potential allergens, what to look for on the label. You might even have some additional comments on, like I mentioned, like scheduling things on different days, isolating things, requiring a deep clean or sanitation process in between batches. This is kind of the general format. I didn't get too specific on this because I just want to show you like the general layout. But the key thing there is that table. You want to make sure for whatever group of products is being produced in that facility, you have a very well known, understood, and accurate list of all the potential allergens that exist in your facility among the different products you have. And you want to make sure that you exercise your allergen control programs or your preventive controls accordingly. Um, as always, exactly how that would be executed really depends on the company. But like I said down there, you can see the additional precautions. Those are some of the many ways you could control for allergens cross contact in your facility through this program or this preventive control. I guess the only other thing I would probably put on here, as far as what, in hindsight, like what I might have forgotten. You remember how I mentioned that labeling could be allergen control CCP? Well, you might even add a label checking here in part of the allergen preventive controls, just to make sure that it has the right barcodes, has the right ingredients stated on that. That's another thing you could do as far as reacting to the potential allergens in your facility. But aside from that, I hope that's relatively straightforward. I mean, what would you do if your friend came to your house and turns out he's allergic to peanuts and you're making like a bunch of different things at once, right? I'm pretty sure that you'll probably do your best to make sure that if you are going to feed people with peanuts, you make sure that that guy has no runs into no risk of coming in contact with those peanuts, right? It's the same thing with the factory. Now, with sanitation preventive controls, it's very similar to the supply chain in which you have to sort of flesh out how exactly you're going to keep your facility clean, specifically with the equipment and the places in the environment where you're going to, you know, deep clean it, sanitize it. Um, how would you check for signs of bacteria, like the ATP swabbing thing? Which like corners you would pick, which equipment you'll swab on a regular basis and test. The only other thing that you would add there is a lot of preventive controls programs for sanitation contain something that's called hygienic zoning. So this kind of goes back to the thing I discussed with the floor plans when I talked about facility design as a GMP. You want to get a good idea of what your floor plan for your facility is and sort of draw this out. And what you would do is you would list the different rooms in your facility, parts of the office, the maintenance room, the different hallways that connect to different areas. But most importantly, you want to talk about the areas that are related to food processing. So there's going to be some areas in your facility that are going to be more vulnerable to environmental contamination than others. This is especially important for, really this is important for anything that requires sanitation, but which is most food processes. But where this is especially vital would be, like say you're making raw food or something that's ready to eat, where you don't have a whole lot of protections. There's going to be one area where the materials is going to receive the most exposure to bacteria from or other hazards from the outside. And so that area needs to be what's in FSPCA or PCQI, HARPC, whatever. This is called a controlled access area. So this looks like some kind of I'm not sure what product this is really, but you can see the different rooms in this map. So the areas that have absolutely no direct contact with food whatsoever, like the commercial office, the bathrooms, the entrance to the factory that the guests come into, the warehouse where the box is already closed, maintenance areas and whatnot. Those are not considered part of the manufacturing area, and so while they still have to be listed on a hygienic zoning map, you would consider these like a non-manufacturing or non-food safety related area, and they're designated accordingly. If there's any connection point between rooms, like a hallway or some kind, or maybe some sort of walkway or gate or whatever, you consider that like some sort of transition area, and so you mark that accordingly too. Areas where there's some contact with the food, but it's not the highest risk, those can be controlled by regular employee GMPs. And so you'll designate those. That's the majority of the facility that's related to the processing area. That should be okay. It's only where there's going to be the most direct contact to the with the food, or where it's most critical to control the food safety. In this, there would be the most risk of exposure to environmental slash employee related pathogens or any sort of other contamination that could occur. So this is an area where you want to be extra sensitive. And it is those areas that are considered controlled access. So in this case, or actually in the general case, like maybe you would have a special ID card that only some employees can get into. They might wear a special color lab coat, and they're not allowed to go into other areas, and vice versa. So like not only can the raw employees only work in that area in between the halls, you want to make sure that anyone working in any other room doesn't go in as well. They might have to wear like special equipment. Like some places actually wear bags over your shoes, step through a foot bath, or like I said, different colored lab coat. Those are all different ways you can sort of like enforce like a controlled access or hygienic zoning policy. So yeah, in short, if you have a sanitation preventive control, you want to have a map of the different areas that are in your facility. If you have a hygienic zoning policy or program, excuse me, you want to list the areas which apply to the program. So you have some which you still need some food safety precautions, but GMPs is enough. And then you have a specialized zones where they're dedicated to being extra strict on the sanitation part. And then you have to have a separate page listing all the different procedures and policies that you have in place as well to go with it. So here's some resources because I don't have enough time to cover everything. On Canvas, I've uploaded a couple things for you to use. The one that surprised me the most was the PCQI manual. So there's something called the FSPCA PCQI course participant manual. That's the kind of the manual or the book they have to use when you're doing PCQI training. That book is normally not free, so I did not share my copy, but I managed to run into one on the internet somehow. I guess someone was generous enough to share it. They're not supposed to, but it's there. So as such, I've uploaded it onto Canvas for you guys to take a look at. It's actually a great resource for like seeing the different kinds of hazards or template that might apply to your operation. They give you ideas of certain templates that you can use for your preventive controls if you decide to use that. If you want to use the HACCP route instead, I have a handout on distinguishing between CCPs and CPs. So critical control points versus regular control points to get you a better understanding on that. There's a project assignment template for HARPC in week 9 as well for if you want to do the HARPC route. I have HACCP templates on. They should be in the same folder too. If not, you can click on that link when you download the slides for this presentation. That should get you to all the HACCP versions of this for templates that you can work with. I don't know if I did this last week. I don't remember. It's a lot of work to do, but like I know for a fact that like in week 8 I added a bunch of like notes, stuff I use for identifying different types of hazards or operations. So you can use that as an additional resource that should be good for both, really. Your textbook has other CCPs that you can use for reference. Then also have some guidance on FDA preventive controls. Again, in week 9 on Canvas. I'll see if I find anything good on YouTube to add to our YouTube channel, but for now, just use those resources. I think that would be best for now, at least for the moment. Now, as for your project, it's November by now, so I'm hoping that most of you have decided to draw a basic flow diagram. Doesn't have to be 100% accurate. That's fine, but just try to do your best to make sure you have an understanding of what process you want to use, and it makes the sense to you and your team. You started going through the hazard analysis, or at least thinking about it at this point. Once you're done with the hazard analysis and the flow diagrams, start deciding whether or not you want to go the HACCP or HARPC route. You can use both, actually, in practice most of the time for SQL certified facilities. That is the case. They use HACCP and HARPC together. If you haven't done either of these things, review those lectures again, as well as this one. Reach out to me if you need help. But at the very least, within this week or the next, start looking at potential preventive controls or critical control points that you can use for your process, and then start breaking them down. The key way to do this is to think about the points that are most important to your project's process for food safety. So, like, if a particular step in the process fails, what happens to that bacteria? What happens to the allergens? Could something like a bone or something get into your food if you neglect something? Uh, Take all those things into account when analyzing the potential food safety problems of your project, of your product. Yeah, and like I said before, if you're unsure of that, just reach out to me. I even do office hours if we need to over Zoom. But if there are no more comments or concerns or questions, I will see you guys next week.